The potential for interplanetary communication and TREVL. Scientists and engineers are preparing for possible travel into interstellar space, the area in between stars, in the distant future. A new report examines the possible problem of changes in language on long space trips. Only 2 spacecraft from Earth have reached the mysterious area known as interstellar space. Scientists identify interstellar space as the area outside the area of particles and magnetic fields created by the Sun. Experts believe it will likely take many years before the technology and equipment are developed to send humans to this unexplored area of space. But if it does happen, massive spaceships could carry humans on long trips to distant stars. 2 American researchers have explored one possible problem with such travel. They considered the possibility that changes in human language could develop over time and lead to major communication problems with people on Earth. The language experts are Professors Andrew Mackenzie from the University of Kansas and Jeffrey Punske of Southern Illinois University. The 2 recently published a paper on the subject that appears in the European Space Agency's online publication Acta Futura. The paper considers very long trips necessary to reach interstellar space, estimated to be about 18 billion kilometers from Earth. It also examines the possibility of future colonization of distant stars. Languages naturally change as communities grow more isolated from each other, the researchers note in the paper. The long isolation of a community could lead to enough differences in language to make it impossible for community members back home to understand. If you're on this spaceship for 10 generations, new concepts will emerge, new social issues will come up, and people will create ways of talking about them, Mackenzie said in a statement. Such vocabulary would become specific to only that spaceship. People on Earth might never know about these words unless there's a reason to tell them, and the further away you get, the less you're going to talk to people back home. The researchers noted that in addition to new words being used, the language of people traveling on spaceships and living in colonies would experience many other changes. For example, the sounds of different letters would likely change over time, affecting not only individual words, but the whole grammatical system, the paper states. Major changes in word and sentence structure could also create systematic language barriers over time, the researchers said. Given more time, new grammatical forms can completely replace current ones. NASA's Hubble Space Telescope has taken this stunning close-up shot of part of the Tarantula Nebula. This star-forming region of ionized hydrogen gas is in the Large Magellanic Cloud, a small galaxy which neighbors the Milky Way. NASA/ESA. The paper provides examples of how languages developed on our own planet because communities became isolated over time. Examples include the Polynesian settlement of far-flung Pacific islands and dialect development in relatively isolated European colonies. Mackenzie identified an example of a major language change on Earth during modern times. He described a way of speaking called uptalk, when speakers end statements with a rising tone. He said this way of speaking is often mistaken for a question tone by those who are not aware of it. Uptalk has only been observed occurring within the last 40 years, but has spread from small groups of young Americans and Australians to most of the English-speaking world. The researchers say one possible solution to limit communication problems would be to include language experts on spaceship crews. Another suggestion is to use sign language as a form of communication. Mackenzie added that space travelers might question whether it is even worth trying to learn how to communicate with people on Earth. But he believes there will always be a need, even if it is very limited. You have to learn a little Earth English to send messages back, or to read the instruction manuals and information that came with the ship, he said. Interstellar space travel. Fantasy of every 5-year-old kid within us. Staple of science fiction serials. Boldly going where nobody has gone before in a really fantastic way. As we grow ever more advanced with our rockets and space probes, the question arises, could we ever hope to colonize the stars? Or, bearing that far-flung dream, can we at least send space probes to alien planets, letting them tell us what they see? The truth is that interstellar travel and exploration is technically possible. There's no law of physics that outright forbids it. But that doesn't necessarily make it easy, and it certainly doesn't mean we'll achieve it in our lifetimes, let alone this century. Interstellar space travel is a real pain in the neck. If you're sufficiently patient, then we've already achieved interstellar exploration status. We have several spacecraft on escape trajectories, meaning they're leaving the solar system, and they are never coming back. NASA's Pioneer missions, the Voyager missions, and most recently New Horizons have all started their long outward journeys. The Voyagers especially are now considered outside the solar system, as defined as the region where the solar wind emanating from the sun gives way to general galactic background particles and dust. So great, we have interstellar space probes currently in operation, except the problem is that they're going nowhere really fast. Each one of these intrepid interstellar explorers is traveling at tens of thousands of miles per hour, which sounds pretty fast. They're not headed in the direction of any particular star, because their missions were designed to explore planets inside the solar system. But if any of these spacecraft were headed to our nearest neighbor, Proxima Centauri, just barely 4 light-years away, they would reach it in about 80,000 years. Speed Racer. To make interstellar spaceflight more reasonable, a probe has to go really fast, on the order of at least 1/10 the speed of light. At that speed, spacecraft could reach Proxima Centauri in a handful of decades and send back pictures a few years later, well within a human lifetime. Is it really so unreasonable to ask that the same person who starts the mission gets to finish it? Going these speeds requires a tremendous amount of energy. One option is to contain that energy on board the spacecraft as fuel. But if that's the case, the extra fuel adds mass, which makes it even harder to propel it up to those speeds. There are designs and sketches for nuclear-powered spacecraft that try to accomplish just this, but unless we want to start building thousands upon thousands of nuclear bombs just to put inside a rocket, we need to come up with other ideas. A spaceship for ants. This is where the rubber meets the interstellar road when it comes to making spacecraft travel the required speeds. The laser itself, at 100 gigawatts, is more powerful than any laser we've ever designed by many orders of magnitude. To give you a sense of scale, 100 gigawatts is the entire capacity of every single nuclear power plant operating in the United States combined. And the spacecraft, which has to have a mass no more than a paperclip, must include a camera, computer, power source, circuitry, a shell, an antenna for communicating back home, and the entire light sail itself. That light sail must be almost perfectly reflective. If it absorbs even a tiny fraction of that incoming laser radiation, it will convert that energy to heat instead of momentum. At 100 gigawatts, that means straight-up melting, which is generally considered not good for spacecraft. Subscribe to Spacefied for more space videos. Thanks for